It's time for fun with math, and today we are going to go over this homework video activity called Working with Inverse Trigonometric Functions. So the activity is designed to review the homework problems from the My Math Lab assignments, Inverse Trigonometric Functions 2 and Inverse Trigonometric Functions 3. And so we're going to start off with trying to find the value of this expression, tan inverse of negative root 3. And remember, the idea of this is that tan inverse of negative root 3 isn't just any number, it's an angle. So once I write the angle theta, then I can solve this. So the way we solve this is we tan both sides, because basically we have an inverse trigonometric equation in a sense. So we tan both sides, and once we tan both sides, and notice the tan's on the left, it's being applied to something. The tan to tan inverse undo each other, and we get negative root 3 on the left, and we get tan of theta on the right. And now this is a trigonometric equation we've solved before. So remember, the way we solve trigonometric equations is we got to go find where that angle theta is going to live. So we write all students take calculus. And because the tan of the angle is negative, I know it cannot live in the first or third quadrants, because in these two quadrants the tan is going to be positive. So it must be in one of these two. And then because you're doing the tan inverse, you're going to have just one answer. So we have to decide, is it going to be in the second quadrant or the fourth? So the idea is that you start here and you want to go to the one that's the easiest to get to, basically. And you can go up and down. So it's actually going to be this quadrant because it's the easiest to get to. You just go down, so the angle lives down here, so that's your theta. Whereas if you went this way, you have to go all the way around, so you have to go further, so it's not this one. If you get stuck on this, remember you do have a calculator to kind of help you. You already know what the answer is going to be if you use your calculator. So on here, do second tan, and then do negative second square root of 3, and then hit enter, and you can see your answer is not positive, it's negative, so that means the angle is going down. So I see the angle is going down. I have to find it now without my calculator, even though I can use my calculator to kind of check my work and check my intuition. I'm not allowed to really do it to do the problem. And so right here is my reference angle. So I have to find that reference angle. Now remember, to find the reference angle, I'm going to have to make that reference table again. So let's practice this. So I have my angle theta. And so remember, you have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And then you can write these in terms of radians: 0, pi over 6, pi over 4, pi over 3, pi over 2. And then for our table, we have the sine of theta and the cosine of theta. And we have to remember one, the sine of 0 is 0, so this is actually root 0, root 1, root 2, root 3, and root 4. Let's fix that 3. And then these are all divided by 2's. So divided by 2, divided by 2, divided by 2, divided by 2, and divided by 2. And of course the cosine of theta is exactly the same, you just write it the other way. So it's just root 4, root 3, root 2, root 1, and root 0. And these are all divided by 2's. Now, of course, no, we're not working with the sine or cosine, we're working with the tan, so we can make an extra line down here for the tan of theta. And remember, the tan of theta is just the sine of theta over cosine theta. So it's just 0 over, remember this is 1, so just 0 over 1, so that's 0. And then this one is 1/2 over root 3. And so that's a little tricky to find, but when you simplify it, remember what you get. You actually get root 3 over 3 when you simplify it. This one's easy because it's just this divided by this, which are the same thing, so that's 1. This one's root 3 over 2 over 1/2. When you simplify that, you just get root 3. And then this one is equal to 1 divided by 0, which is undefined. So it's undefined. All right, so what are we doing? We're trying to find that reference angle when the tan of the reference angle is basically root 3. So you see root 3 here. Oh, and so the reference angle must be pi over 3. And so that means this angle here is negative pi over 3. And so our reference angle here, which I don't have enough room to write, but our reference angle is just pi over 3, which makes our actual angle theta negative pi over 3. And the question then becomes, is that our actual answer? Well, we know what the answer is supposed to be. It's supposed to be that, and we can check it. It's negative second pi divided by 3. Is that negative 1.047? Yes, it is. And so that's what the tan inverse of negative root 3 is equal to. Let's take a look at the next problem. So the next problem, we have the cosine of tan inverse of negative 2 over 3. And so how do we solve this one? So again, remember, the idea is that the tan inverse of negative 2 divided by 3 isn't just anything, it's an angle. So this is going to be equal to the cosine of an angle. So cosine of theta, where theta is equal to what? Theta is equal to the tan inverse of 2 over 3. And so on this one, we want to find where theta actually lives, but then we can actually make a right triangle to solve this problem. So let's go find where theta lives. Oh, and this is negative. That's important. That's negative 2/3. So over here, let's make a nice big xy axis here. And then we'll write all students take calculus. So all students take calculus. And you have tan inverse of negative 2 over 3 is equal to theta. Oh, I need to tan both sides, of course. So let's tan both sides. So tan of theta will equal tan and tan inverse undo each other, and you get negative 2/3. So I should probably have done this first. Now I'm solving this trigonometric equation, so I need to go find where theta lives. So tan of theta is negative, so I know it can't live here or here. It must be in one of these two quadrants. And again, the same idea sort of prevails. You start here, and it's like, what is the easiest quadrant to kind of get to? And it's the one right down here. So I know I'm not over there. And again, you can check it with your calculator to see, okay, well, where does that angle theta live? Second tan of negative 2 divided by 3. And you see it's negative, so it must live down in this quadrant. So here's our theta right here. There's theta. And now, instead of actually finding what theta is, remember, we don't want to find theta, we want to find the cosine of theta. So what we can do is we can make a right triangle here. And I know that tan of theta is equal to negative 2 over 3. And so I know the SOHCAHTOA. All right, so SOHCAHTOA. And because you're doing the tan of theta, this must be the TOA, must be the opposite side over the adjacent. And so the opposite, you have a 2, and the adjacent is a 3. Now, you have to be careful because one of them is going to be what? One of them is going to be negative here. And so the negative goes right here because you're going down. And so if you want to find the cosine of theta, well, that's the it's the adjacent over the hypotenuse. But we don't know the hypotenuse, but we can use a Pythagorean theorem to figure that out. So we know that if you take 3 squared and you add negative 2 quantity squared, it should give you that c squared. And so this is 9 plus 4 is equal to c squared. And so that's 13 equals c squared. We'll take the square root of both sides. And because it's the hypotenuse, we just care about the positive part of it. So root 13 is equal to c. And so here you can write, if you want, c equals square root of 13. And so for the cosine of theta, it's just the adjacent over the hypotenuse. So it'd be 3 divided by root 13. And this is a fine answer, but remember, MyMathLab may want you to rationalize the denominator. So when you rationalize the denominator, you just multiply top and bottom by the square root of root 13. And so that'll equal, you get 3 root 13 on top and 13 on the bottom, because square root 13 times square root 13 is just 13. So that's another good answer. And that's the one my math lab will want. Now you can check your work. So remember, on here, we can actually plug this into our calculator. We take the cosine of second tan inverse, like it has here, and then plug in negative 2 over 3, in parentheses, hit enter, and it spits out this number. Now the question is this number and basically this number exactly the same. So let's check it. We can do 3 divided by second square root of 13, and you see, yes, they're exactly the same. So I don't just think I did it right, I know I did this right by hand. All right, let's look at the next one. So on the next one here, what are we doing? So instead of having numbers, you'll see now we have letters. We have variables now. But it's still a very similar idea. So again, when I look at this, I'm like, I have cosine of sine inverse of x. And remember, sine inverse of x isn't just anything. It's an angle. And so over here, I'm going to write cosine of an angle, where sine inverse of x is equal to my theta. And so then I can sine both sides. So I sine this side and I get x. And then I sine this side and I get sine theta. And from here, instead of doing all students take calculus, all we have to do is draw a single right triangle. So in this one, we're always going to assume you're basically in the first quadrant. That's the idea. And so here's my angle theta. And then remember, this is actually x over 1. And so then I can do SOHCAHTOA. And so I have, for the SO, I have the opposite over the hypotenuse. And so the opposite side of the theta must be x, and the hypotenuse is 1. So I'm looking for this side right here, because remember, I want to find what? I want to find the cosine of the angle. So I need the ka, which is the adjacent over the hypotenuse. So to find a, remember a squared plus x squared, the Pythagorean theorem, is equal to 1 squared. And so I can solve this for a by subtracting x squared from both sides. And I get what? I get a squared equal to 1 minus x squared. And then if you like, we could take the square root of both sides because we're looking for a. So if you square root the left-hand side, you get a. And the right-hand side, it is plus or minus, but we're always going to take the positive piece when we're just working with variables because we're always going to assume this right triangle is living in the first quadrant. And so this is equal to then the square root of 1 minus x squared. And so if I want to find the cosine of the angle, it's going to equal the adjacent side, which is the square root of 1 minus x squared, divided by the hypotenuse, which is 1. And of course, you can just write that as the square root of 1 minus x squared. And so this is our answer. Now we can check our work again with our calculator. So on our calculator, and let's think about this. The idea is plug in a number for x, but you have to be careful about which number you're going to plug in. So for example, if you think you can plug in like the number 2, you're going to have a problem, right? So watch what happens if I try to plug in 2. So second sine of 2, and I hit enter, and it says error, and it says it's a problem with the domain. Remember, the domain of sine inverse of x, that function y equals sine inverse of x, it can only take in certain numbers. X has to be between, remember, -1 and 1. So if you try to put a number that's bigger than 1, it's going to return this error. You can even go to where the error is, and it says, the issue is right there with that too. So what we need to do is put a number in there between probably 0 and 1. I mean, -1 want to work too, but some number between 0 and 1. So instead of 2, let's do 1 divided by 2. And now you'll see you get back some answer. And the question is, if you plug 1/2 in here for x, do you get back the same answer? So let's take a look. Second square root, 1 minus, and then instead of 1/2, let's just put 0.5 because it's easier to write down, squared. And if these two answers are the same, you know you did this correctly because you checked it at one point, and the point was probably random enough that it's not a coincidence. Okay, we're almost done. The last problem I want to do with you guys is solving a trigonometric equation using inverse trigonometric functions. So here we have this equation, 3 times sine squared x minus 1 is equal to 0. And remember the big idea. The big idea is this. You basically, every trigonometric equation, you want to get sine of something, like some angle, equal to some number, or the cosine of some angle equal to some number, or the last one is the tan of some angle equal to some number. If you do that, then we can do this whole all students take calculus business, find the angle, and use the plus 2 pi n or plus pi n idea to find all of the answers. And now let me remind you, we just want the answers on here between 0 and 2 pi. So that I should have written that down, but I forgot. So, but just between 0 and 2 pi is what we want. So first, we have to make it, somehow turn it into one of these forms. And so we're going to solve this equation. We'll basically just add 1 to both sides. And we get 3 sine squared x is equal to 1. We'll divide out by 3. So sine squared x is equal to 1/3. And then we'll take the square root of both sides. And so we get the sine of x is equal to, now here we care about the plus or minus, so it's plus or minus the square root of 1/3, which, remember, the square root goes through division, so it's the square root of 1 divided by square root of 3, so here we have the sine of x is equal to plus or minus 1 over square root 3. You don't have to rationalize the denominator right here because you don't care about this so much as you care about finding x, because that's what we're trying to do, is solve this equation for x. But what happens is from this one equation, we get 2 equations. So we have the sine of x equal to positive 1/√3. And then we also have the sine of x equal to negative 1/√3. And so to solve these 2 equations, basically we've got to go find where our angle x lives. So we draw our sort of x and y axis here. And we write all students take calculus. Let's do the top one first. So the top one, the sine of the angle is positive. So I know I don't live here or here because that's where the sine, I'm sorry. That was my mistake. So again, the sine of the angle is positive, so I know I don't live down here. This is where the sine of angles are going to be negative. So I must live in these 2 quadrants. And so I draw the angles in both of these. Now remember, I draw them in both of them because I'm not doing sine inverse. Right? What I'm doing, this is not sine inverse, what I'm doing is solving this equation. This equation has an infinite number of answers, whereas up here, above, this had only one single answer, so I had to go find that one single answer. But down here, this equation will have an infinite number of answers. Okay. All right. So the sine of the angle. So I know that. So I got to go find this reference angle. So here's the reference angle. But I got to go find it. But the problem is now this angle is not in my reference table because 1/√3 is not in my reference table for the sine of x. So take a look. We did this in the second part up here. You know, look, there's no 1/√3 for sine of an angle. So what we have to do is something different. And so remember, the idea behind this was to do sine inverse on both sides. So we'll sine inverse both sides. Sine inverse over here. And if you sine inverse sine, they undo each other, and so you get the angle x equal to sine inverse of 1/√3. And the question becomes, is this the reference angle? And if you think about it, right, is this the reference angle? You'll see that it actually is, but you can check it with your calculator because sometimes this angle may be negative. And if it's negative, you have to change it to be positive. So here, second sine, and you do 1/√3, you'll see that this answer here is positive, so it is the reference angle, okay? So this is the angle right here, and so what we can do is just write it down. So this is the reference angle is actually sine inverse 1 over root 3. And then we can read off the angles that we want. So for the angles that we want this angle from here to here, and so that's an easy one. That's just equal to sine inverse of 1 over root 3. And then we want this angle from here to there. And so remember how you do this one. Remember, if you go around here, it's all the way around, halfway around, it's pi. We want to go back. We want to go back what? I should write this here, this reference angle again, sine inverse of 1 over root 3. So we want to go back sine inverse of 1 over root 3. So the second angle is just pi minus sine inverse of 1 over root 3. And so my second answer here would be pi minus, so pi minus sine inverse of 1 over root 3. And so there are my first two answers, and these are the only two answers that are between 0 and 2 pi. We didn't have to write the plus 2 pi in because, again, you just have an x, and you're just looking between 0 and 2 pi. Okay. Let's try this problem again. Doing sine of x equals negative 1 over root 3. So basically, it's the same steps. It's all students take calculus. We're looking for where the angle x would live. The sine of the angle is negative, so I know I don't live in these two quadrants. I live in these two quadrants down here. And I can draw the angle. So here's the angle. There's one there and there's one there. And then I need to find this reference angle so then I can read them off. Now I already know what it is because I solved this problem, but let's pretend like we didn't just so you can see how it works. So to find that reference angle, it's not in my reference table, so what I'm going to do is I'm going to sine inverse both sides. I'm going to undo the sign by sine inversing both sides basically, and I'll get x equals sine inverse of negative 1 over root 3. Now what you want to notice about this one is on this one, it's going to be negative on my calculator. So check this out. So it'll be second sine inverse of negative 1 divided by second square root 3. And so you see it's actually equal to negative number above it. So this is not actually a reference angle. And it's not an answer to my problem because notice my x's, all my angles live between 0 and 2 pi. This angle is negative, so it's basically too small. So what do you do in a situation like this? Well, the easiest thing to do is if it's negative and you want it to be positive, is just put a negative sign in front of it. So your reference angle is negative sine inverse of negative 1 over root 3. And over here you just write negative sine inverse of negative 1 over root 3. And so now when I'm reading off my angles for my answers, I'm going to start here and I have to go all the way around to here. And so remember, halfway around is pi, and then I'm going to go plus this additional reference angle. So my first answer would be x equals, and I write pi plus. And then there's a negative sine inverse, so I guess, actually, because it's plus a negative, it would be x equals plus a negative would be a minus sine inverse of negative 1 over root 3, comma, and the next one, this angle all the way around here. And remember, all the way around is 2 pi, and so what you're going to do is go all the way around 2 pi and go back. So minus a minus, so that'll be plus. So this will be pi minus a minus, which would be plus sine inverse of 1 over root, negative 1 over root 3. And those would be my two answers from this one. All right, so you got to be careful about your answers because they want them between 0 and 2 pi. So your answers cannot be negative. Even though, yes, if you go down here, it's negative sine inverse of negative 1 over root 3, you go down there, you're going to get another answer, but it's not between 0 and 2 pi. So you got to be very, very, very careful with these. Now on my math lab, if they want you to rationalize the denominator, realize you can rationalize 1 over root 3 by simply writing this top and bottom, multiplying by 1 over root 3, and so this would be root 3 over 3. So the only difference would be that you take this root 3 over 3 and put it in wherever you see a 1 over root 3, 1 over root 3, 1 over root 3, 1 over root 3. You can also check your work on these. So remember, on your calculator, what I like to do is just to check my work, I just pick one. And I like to pick one just kind of randomly, like this one right here. If this one works, I bet they all should work. So let's just check this one. So on my calculator, what I'll do is I'll do second raised to, which is a pi. I'll add second sine inverse right here, and then I'll type in -1 second. Ooh, I messed that one up actually. So check this out. I just noticed that I messed this up. Divided by second square root of 3. And I noticed I messed this up because when I was typing it in, I realized I just put a pi here. That shouldn't be just pi. That should be a 2 pi. So make sure you make that correction. It should be 2 pi plus sine inverse. That's a hefty mistake. But hopefully I would have caught it up here. So I'm going to fix this. So second enter pulls up the last entry. Instead of pi, I'm going to insert a 2. And so now this should work. So there's the answer. Let's check it by plugging it in to this equation right here. So in this equation, if I take 2 and I'm going to square sine, so sine of this answer in parentheses, and I square that number and I take away 1, I should get back 0. I didn't get back 0, which means something is wrong. All right, I see it. I entered it in incorrectly. So notice that's not a 2, that's a 3. And so on here, to fix this, what do I need to do? I need to do a couple things, okay? So follow along here. So second enter, second enter. I need to pull up that last answer and put that in there. And then I'm going to hit second enter and second enter again to pull up the expression before. And then I'm going to go back. And I'm going to put a 3 here. And now it's equal to 0. So I really didn't make too big of an error. This is the correct answer. But yeah, when you plug in your calculator, if you plug it in incorrectly, it may tell you you're wrong when you're actually not. So you gotta be careful.